Sound check. Sweet. All right, be back, guys. Gonna start at 9 today. Let's test the sound. Sweet. Hey guys, welcome to today's tutorial. Now this one is a bit different. I'm just going to give you guys a bit of an explanation of what's actually happening here. So just to kind of give you guys an idea, because I've never done this before, like in the sense where I've done a tutorial using student Desmos with people before, but the reason I chose to actually do this one today with using student Desmos is because I can actually see you guys working on your answers, and then I can actually give you guys some feedback. Now I've set it up so that the names will be anonymous, which means that like I'm going to show you guys what my screen actually looks like. So just so you get an idea. So as you can see at the moment, I've just clicked on anonymous, so that means I don't know who is actually answering apart from these random names that actually pop up. Now also what I've got here is so for each task I can actually look at how you guys are doing, like what you guys are actually doing for the answer. Now if you want to actually kind of work on an answer, I'm just going to show you guys one question, how to kind of show you how the sketching actually works. So say for example this is what your screen is looking like right now. Now this pencil right here, you can actually use that pencil to actually draw a sketch. Now the reason I'm actually doing this is because I had a look at the exam papers. There always seems to be like a sketch derivative function or sketching like just the normal f of x given f dash of x. So that's why I thought it would be a really good idea to do this. Now look, even if you don't know how to do this, just have a go, because you might actually learn from your mistake. All right, and because let's be honest, I've got no idea who you guys are here, and no one will ever actually know. So to kind of use this tool, what you have is just make sure you click on your mouse or wherever you're watching it. You can click on the pencil tool and kind of just draw, like just draw a line over it if you want. Okay, that didn't, yeah, and then you've got this eraser button, so if you make a mistake you can just kind of like rub it out. All right, or you can just kind of put 2 points and just, yeah, you can also draw like a straight line as well. So yeah, like I said, I mean, this is the first time I'm actually trying this. I've got no idea how this is going to work out, but let's actually give it a go anyway. All right, so in saying that, so if you guys just want to have a go by yourself, that's absolutely fine as well, but I'll actually kind of go through with this one step at a time. So looking at this first activity at the moment, as I can see, there's a few people that have kind of like logged in and had a look at the kind of the answers, but you can kind of see what people are doing. They're all putting this little dot. So I guess that's where we're kind of going to get started with the question 1. So question 1, the problem is I'm going to see if I can try and take a screenshot of it, if it's going to work. No, that's not going to work. Where do you log in? That's a good idea. I should have actually put that out there. There we go. Try that. Yes. I will actually put it up in just give me a second, guys. I'm just going to put it up in the description link. I was supposed to do that. I kind of forgot. Okay, as I said, apologize guys, it's the first time I'm trying something like this, so you might just need to refresh your stream. If you do refresh your stream, in the description section you'll find the website and the code for you guys to go have a go at. Okay, Now, Jules, you're not the only one. Trust me, level 1 is just annoying. That's all it is. Level 2 is a lot more pretty straightforward, to be honest. Okay, so let's have a look. Now, I'm starting to see some answers popping up. That's really cool, guys. So I'm going to give you guys, like, you know, and by the way, if you are comfortable with this, just keep going with these questions, and then I'm going to go through each one of these questions one at a time, all right? Where did my snip? Snip, snip, snip. Why won't you work? Because I'm streaming, that's why. Okay, that's fine. Is that gonna work? Yes. Okay, sweet. Yeah, I think you guys got the general idea there for this one, because this is a nice, I think usually this one is the achieved one, so it's not too bad. So I'm just gonna kind of pop up one here and just show you guys. So yeah, so basically what you need to understand is that the gradient is actually 0 at this point. So because the gradient is actually 0, that means it's you're gonna put a little point like that just to start out with. Now the next thing is to have a look at along this side here. I wonder if I can actually write with this on the screen. I can. Sweet. Okay, let's do that. So what I'm going to do is I'm going to show you guys this, right? Before the gradient turns to 0. So all along this part here, all along the green part, the gradient is actually negative. All right? And then all along after the gradient is 0, the purple part, it's actually going up, so that means the gradient is positive. Now also remember, this graph that you're looking at right now, the red, it's a parabola. We know that the parabola, this is not going to work. Oh, I see. So if it's a parabola, it's actually x squared. That means when we differentiate x squared, we are going to get 2x as the differentiated function, which means we're looking at a straight line. So when we actually draw the derivative function, as long as it's a straight line and it actually goes through that, okay, that doesn't go through that point, but you know, it's really hard for me to draw it on this, and I know it's hard for you guys to draw it on it, but when you guys actually draw it in your exam paper, just make sure you go through that blue point there. Don't stress too much about the slope. Like when I say slope, I mean you might have actually drawn it like this, but as long as it's a straight line and it actually goes through this point right here, that's the most important thing. Okay, cool. So that's usually an achieved question, guys. Now, is there any kind of questions with that? Because I'm just having a look at and I'm looking at it. Most of you guys got the straight lines correct there, apart from a couple of people with some lovely messages. Thank you for that. So is this all right for a basic achieved derivative question? Yes, Maya. That's why I'm actually spending almost an hour on this, because there's two types of questions they could ask you guys. One is an achieved question like this, where you just sketch a graph, and then you have a merit one where you go backwards, and we will actually do some of that today. So I'm looking at 8 graphs today, but once you do those 8 graphs, trust me, you're covered for this, which means if you nail this 8, you are most likely going to get a 5 point, if if it pops up as a merit question, and you'll get 2 points for achieved if it pops up. And sometimes they actually separate it. No, Crystalline, it doesn't. But as long as you have that, like, what do you call it? As long as you don't have to have the rough straight line shape, that's the most important thing. But at the same time, you don't want it, you can't do this. I mean, if you have, say, for example, going like this, which is negative, definitely that'll be actually incorrect. Angie, no, you don't need to actually find the equation of the parabola. They'll only say like sketch derivative. That's all they'll say. Because I'll show you guys, this was from the exam papers this was last year's exam pointers with that yellow line. So I kind of just taken a yellow line and just drawn underneath it. And that should be it. Is my stream kind of slowed down? Okay, I've just gonna reload because I think, can you guys hear me? Oh, no, we're good. Yeah, sorry guys, just kind of I think I can't actually have too many windows open, otherwise it kind of slows down. But yeah, Hugh, as long as your slope is not too off, you'll be all right. As long below 0 to above 0. Yes, it has to go below 0 before the turning point and above 0 and as a correct turning point. Yep, that's all fine, Hugh. So you should be fine with that. Okay guys, I just want to have a look at, because I'm going to get rid of this right now, and I'm going to have a look at your answers just to give you guys some feedback. All right, so yes, this person here, that's fine, that's all good. There's too many going here. You probably just want one. Yeah, I think you guys are pretty much good to go with that. That's sweet. Okay, let's go to the second one here. And I'm going to pick a one to kind of choose from. Okay, so the second one, first thing is always look at the turning point, all right? The turning point is when the gradient is changing. So the turning point is right there. And because the turning point is right there, I'm going to see if I can go student. Yeah, let's try this. Okay, so because the turning point is there, what I'm going to do is I'm going to put my point here. And also this happens to be a negative parabola. So it's going to look something like this. And if I differentiate it, I'm going to get negative 2x, which means this is going to be a straight line. And if you look at it, before the turning point, the graph is actually increasing. And after the turning point, the graph is decreasing. So that means it's got to be positive before the turning point and then negative. So what we're going to get is a straight line, something like this. If I have y equals 2/6 x minus 2 rather than y equals... get vexed, you should, because unless... I think you should be fine with 2/6 x minus 2. Okay guys, so again, this is another easy achieved question right there, and I think this was very similar to the one in last year's exam paper. And also remember, I'm using the particular language, like so the green shaded region here, that's when the gradient is positive, but they also say something like the graph is increasing. When they say the graph is increasing, that's when, hang on, I'm just gonna mute myself a bit. Yeah, so when it says it's increasing, we're looking at the green zone here. And when it says the gradient is positive, we're also looking at the green zone here. All right. When they say the graph is decreasing, we're looking at the purple zone. And also they also say that the gradient is negative there as well. So that's what we're doing for question number 2. Just want to have a quick look at your guys' answers. What have we got? Beautiful drawing there, Simeon. I think the only one that I have an issue with is this one here. Your line is like a little bit too steep, because remember your parabola has to have like it looks like a normal parabola, so you can have the slope a little not as steep. That's what I would say, but I think you probably would still get it marked right. So for this question here. Okay, so let's go to the next question here, which is question 3. So question 3, what you have to understand is that first you're looking at, you've got a cubic here, all right? Now cubic means it is x to the power of 3. When we differentiate it, we are going to get something like 3x squared, right? So that means we're looking at a positive parabola. That's what the derivative function is going to look like. So our first step is to actually try and figure out where our turning points are. So we've got one turning point there, and we've got one turning point there, which means this parabola is going to cut at those 2 points there. All right? So kind of like just drawing it right there. I don't know what's happening with these points. So, and we also know that it is a positive parabola, and that's basically it. So if we have a positive parabola, just kind of what you're going to do is it's going to go below there. Something like this, but make sure it goes through those 2 points there. Because I'm talking about these turning points right here. Because if they don't go through those 2 points, you would actually be marked incorrect. Now, some people might be wondering, well, why can't a parabola actually look like this? I'm going to show you guys another parabola. This time I'll choose, say, green color, for example. So as long as it goes through that, could look like this. All right, so we don't know. We don't know. But as long as it goes through those 2 points where the gradient is equal to 0, then you're pretty much good to go. Okay, I just want to have a look at your guys' answers and give you guys some feedback. I'm always nervous about this because there's always some interesting messages. Yes, Wakanda forever. Okay, so most of you look okay, because I think I have to assume that you guys are actually drawing with your pen, so therefore it's going to be pretty hard. Also, guys, one other thing is, like, just stretch out the quadratic a little bit more to the top. So I'm talking about, like, so someone like this person here, you could just stretch out that parabola a little bit more higher, like almost something like this, what Rene Descartes has actually done here. All right, and so this, obviously this parabola is a little bit too low, but if I put it all on top, see, there you go, you guys got the idea there. Most of you guys' parabola is actually going through these 2 points, and that's what's important. Any questions on that so far? Atul, Jaden, a shout out to you. There you go. Sorry, I just saw that now. All right, guys, no questions. I think this is still an achieved question. We're not getting to the merit till question 5, 6, 7, 8, but let's do one more achieved question. Okay, Maya, that's a really good question. Just going to go back to question 3 just to show you. This was the work that I'd actually done. How do you know it's positive or negative? Now, if you look at, I'm going to choose my colors. I'm going to choose green color here. So I'm looking at the cubic, right? Now look at this part right here. I'm just going to color just up to the point where the turning points happen. So this entire green zone is actually positive. So that means in the parabola, before the turning point, everything is positive. And so remember, all this is positive, and below the x-axis is all negative. And then if you look at the orange shaded part of the cubic, which is from here all the way to there, so the orange part is negative, which is actually this part of the parabola that I've shaded. And I know I'm kind of throwing a lot of colors in here, but it's just I'm missing my highlighters. And if you look at it for the cubic, from this turning point and going up, it's positive. It's positive again, the gradient. That means the parabola is actually positive. So to give you an idea, Maya, if your graph is increasing like this, a cubic, then that's positive cubic. If it's decreasing, then it's negative cubic. And then when you differentiate them, you're going to get 3x squared and negative 3x squared. Okay, let's go to question 4. So I'm going to show you question 4 here, Maya, just so it kind of makes sense here. Now, what we've got here is a negative graph, but there is another way to do this as well. So I'm going to do it this way. So I'm going to color in wherever it's positive, wherever the gradient is increasing or positive with green color. So basically, this is the turning point. So from this turning point to this turning point, the gradient is positive, right? So because, let me put my 2 points here. So those 2 black points are my turning points where the gradient is actually 0, right? So between those 2 zones, it's actually positive. And the only way you can draw a curve that's positive is, I'm going to choose, what color should I choose? I'm going to choose blue. So that means, see how the parabola happens like this? So the blue line is positive for the cubic. So that's the green shaded region. Then if you look at the cubic before the first turning point, which is the orange part, that's when the gradient is negative. And after the turning point, the gradient is negative. So because it's negative, it's below the x-axis. And after this point here, it's negative. Therefore, it's also going to be below the x-axis. And you can see how the parabola is actually forming right now. All right. Are we okay with that question? I'm just going to have a look at what you guys did. Got some tanks, Got some nice work. The person that actually wrote, Mr. Stark, I don't feel so good. Your parabola is looking a bit funky, so I might actually try and do it more in a parabola shape rather than like a straight line kind of coming up like that. But yeah, most of you guys, again, I think you've got the hang of it at the moment with the with this one. Okay, so those were all the achieved questions, guys. Now let's go to the merit questions. So we've got to go backwards for the merit questions. And this is awesome because there's already so many kind of wrong answers, as you guys can actually see. So that means we're going to be learning from this particular experience, because I know this was going to happen. Okay, so what we've got here is in this one, so these are the answers you guys have actually given me at the moment. We've got positive parabolas, we've got negative parabolas, but let's actually have a look at it. Right now, so what we've got here is we've got a straight line, right? Now, when you have a straight line, we know that it has an equation of y equals mx plus c. Let me just show you guys, just to give you an idea. So this is what the equation, so this is example number 5. So what we have is we've got f dash of x, right? So this is what f dash of x is. F dash of x is a straight line right now. Now you don't need to worry about the gradient or the y-intercept or anything like that. All you need to worry about is that it's a straight line. That means it's going to be something times x plus something. We don't care about that something. All we care about is it positive, the gradient? Yes, it is, because it's going up. And it's x by itself, which means if we integrate it, all right, if we integrate x, then what we're going to get is x squared over 2. And again, we don't care about the 1 over 2. All we care about is that it's x squared. So if you want to draw a f of x for this red little line, it's going to be a parabola, and it's going to be a positive parabola. The reason it's positive is because your line is actually increasing. It's actually going up all the time. All right, so that's how we know that we're going to get a happy face parabola. So if we go back to our diagram, then there's a couple of extra bits of information that you need to know, because it says the graph of the function f of x passes through 0, 5. All right, so that's our first thing. We actually need to make sure that this parabola actually goes through 0, 5. But here's the other thing though. Your turning point is when x is equal to 3. And because your x is equal to 3, as long as your turning point is below this line, so let me just show you guys the types of parabolas you could actually have. So I could have, maybe the turning point is there, so the parabola could look something like this. Or I could have a turning point here, and that means the parabola could look something like this. Or I could even have a turning point down there, which means the parabola could look like this, because that's still a turning, like right here, even though it's at the bottom here, that's still a turning point. So the two important parts that they will look for this particular question is is your graph actually going through 0, 5? That's number one. And the second thing is that is your turning point somewhere along when x is equal to 3? So it could be down here. But what you can't have is you can't actually put a turning point above 0, 5, because if you do that, then what you're going to end up with is a negative parabola, and that's actually incorrect. All right, so that means as long as your turning point is below the red line, then that will actually make it a positive parabola. Okay, is that all right, guys? So that's basically what they're looking for a merit grade. For a merit grade, they want to make sure that you actually go through 0, 5, and also that you have a slope, not a slope, you have a turning point when x is equal to 3, because that's where the gradient function is cutting it at. Any questions on that? I'll have a look at what you guys have done. You guys are starting to fix that up. But yeah, apart from that one negative parabola there, most of you guys seem like you've got the kind of idea behind it. Cool. Let's go to the next question. Want you guys have a look at what you guys have done. Yeah, I think you guys got this one. Yeah, I don't think I actually need to do this one for you guys, because most of you guys have actually got the hang of this one, except for the person in orange. Remember, it says there's a turning point at 2, 3, which means, going back to the question, because it has a turning point at 2, 3, just make sure that that's where the parabola is actually going to change. And also this line is a bit steep, which means your parabola is going to be a bit more skinnier than usual. No, Crystalline, you don't need to find the equation for the straight line at all. It helps if you find the equation, you can actually calculate, what do you call it? You can actually integrate it and get a correct equation, but it's a waste of time. So yeah, so that's basically how you guys do question number 2 there. I love how people are so creative in this area. Okay, apart from this person with this parabola here, you can see it kind of messing up. Okay, let's go to the next question. Is there any other questions for question number 6? Sweet, let's go to the next one. Let's see what you guys did in this one. Okay, we got a cubic. Yeah, so we got a few little answers here. Yes, Micah. All the question, I don't think 6 was a merit, because I made a mistake with the write-up for that question. But 5 is definitely a merit. This question right here, sketch FX number 3, will definitely be a merit. I'll see if I can show you that question. I know we had problems loading it last time. Is it going? Yeah, so I will show you the merit question because I know I had some streaming issues. That's your achieved one. So this question last year was a merit question. Night Shadow, if you are just joining in, yes you can. Check out the description below in my stream, like in the description box, there's a link for all the work. So who was asking me this? Micah, yes. Yes, it is easy, Micah. That's why I'm spending almost an hour on this, because once you get the hang of it, it's an easy 5-point question for a level 2 calculus paper. And I think almost every year I've seen that. So as you can see, this was a parabola that was given, and then I had to draw basically a cubic. So the question number 7 we're going to be doing is very similar to this question. And as you guys can see, they kind of give you the clue that the graph of the equation passes through 0, 3. Sorry, it's a bit tiny, but you know, that's what it is. And then if you guys look, what I've done here is all I've done is I've just taken a highlighter and just traced those turning points. And then once I get the turning points, you guys can see how I've actually done it. And notice I've actually drawn 2 answers for this question, because I don't know what shape it could look like, but as long as it has that shape, which is a positive cubic right here, like I hope you guys can see it. Why does my mouse doesn't pop up sometimes? Okay, so I'm talking about this shape here. Because if we have and again, look at this part of the notes here, because it's x squared, when I integrate it, I'm going to get x cubed over 3. And therefore, as long as it has that positive cubic shape, which is that red line that I've shown at the bottom here, then you're pretty much good to go. Okay, so let's go through question 7 here. Just want to have a look at how you guys went. Someone's got a bit angry. Marianne. Okay, so let's actually show you guys anyway. So what we have is, first off, understanding that I actually like what this person actually did here, because it makes sense. I'm just gonna kind of pop up here. See, what this person has actually done is drawn like 2 kind of like straight lines where the turning point is. So what you will see is, like, I'm just going to draw over it. See how the cubic, as long as it has a turning point on that green line and has another turning point in that green line, you are pretty much good. But can I ask you guys one question? Now have a look at this question, and can you tell me why I'm only going to give this person an achieved for this? Just a generic shape, Micah, but don't use like a pen, not a pencil, but like don't do like a sketch. When I say sketching, like don't do like an art sketch. Just do like one nice line. And they usually give you like extra grids anyway in the back of the exam paper if you make a mistake. Yes, thank you, Unshackled. Thank you, Micah. The reason why this person is not going to get a merit for this question is because the graph doesn't actually pass through 0, 5. So they need to have done this. They needed to have put that point 0, 5 there, which means this graph should look something, I mean, it could have looked like that, but as long as it goes above the 0, 5, comes back, and you know, even something like this, it's absolutely fine. And I think that's what you guys got to be careful about, is that just double check that you are actually covering all the bases for your question. Okay, and it was pretty easy. You guys picked it up right now, and that's why this person would not have actually got a merit, even though they had a beautiful way of setting it up with the two green lines and then sketching the cubic. But the problem is it didn't go through 0.5, therefore it would not be a merit. But wouldn't it then be negative? No, because Micah, it's not a negative, because if you look at the difference between the blue cubic and the black cubic, is the black cubic's actually risen up, that's all. All right, I mean, you could have had a cubic that looks like this. Let me just show you another one. You could have had something that goes from here and then has a turning point at the green line and then come all the way down like this and then change here and goes like this. It doesn't matter. Yeah. It's an increasing cubic because it's a positive cubic. So that means it's going to be positive towards the end. All right. Are we okay with this question, folks? I'm just going to close this because whoever this was, thank you for your input. What about this person here? Would they get achieved or a merit for this question? No, it doesn't make sense, Micah. I think my only complaint with this person is that maybe they're using I can see that they've got the idea of it going through 0.5, but they needed to make sure that second turning point actually goes through the orange line. So if they had done something like this, then I would have actually given this a merit. And as long as it went through, yeah, like that, then I would have given it a merit. Simon Chan. In this particular question, it actually says 0.5. That's why it's going through 0.5. So you could actually have different questions. Like, for example, I think in the next question, I had something else. Yeah, so they'll just give you a different point. You can kind of see the point here. Can you see the mouse? Is it going to show the mouse? Is it going to show the mouse? No. Oh, no, there it is. Yeah. So as you can see, in this question, it actually says 0.5. So that's why we make it go through 0.5. For drawing, Micah? I have not seen a sketching for a double differentiation, not that I could think of. Because even if they do ask, the only thing they could ask you is like they'll give you a straight line, and then they'll ask you to double differentiate, but they'll have to give you some points. They can't just be like, just do it straight away. No worries, get vexed. Enjoy. So they'll give you, like, you know, in this question I've given you like one kind of information. They will have to give you like 2 bits of information for you if they ever do that. Let me see if I can actually create a question like that. I might actually post a video, but yeah, that's basically it. Okay, let's go to question number 8. What was the overlay like? I think most of you guys, yeah, most of you guys had it right, except I had a really good Leonard Euler. So having a look at this one, I mean, that would be for kinematics if they do it right. Yes, Micah, so that would be for kinematics, which we will spend another one whole tutorial on just kinematics. Like, I'll find all the kinematics question put together and then we'll do a question. Now this person here, the mistake they've done is they've actually drawn the purple line, but they needed to make sure that the turning point is actually on the purple line. Yes, it goes through 0, 5, but I'm not going to give this a merit for this question. I'm only going to give this an achieved. And that's because the turning point is actually not on the purple line. Welcome, Aaron. See you later. All right, last question, and then we shall be done, guys, because yeah, it's a short session today. Okay, so with the last question, I'm actually going to use that previous person's idea of drawing 2 lines where the turning point happens, which means it's going to look something like this. Now, if you have a look at the question also says that you've got a y, the graph of the function has a y-intercept at -3. So Simon Chan, because it says y-intercept at -3, we need to make sure that this graph actually goes through -3. All right, and we also have, this is going to be a negative cubic, because think about it, right now we have a negative parabola, and if we integrate it, we are going to get a negative cubic. And a negative cubic looks like this. You're welcome, Jaden. So I'm going to kind of sketch this out. Obviously, my turning point cannot happen below the X mark, because if it does, then I will have to actually bring it back like this, and I won't be able to make sure I can go through the y-intercept, which means I need to have my graph gonna go something like this, where it's a turning point, and go along like that, turning point, and then come back down. So let's have a look at what you guys actually have done. Got the generic shape, but let's have a look. Want to pick a couple of them. Actually, this is a good one right here. All right, tell me, guys, what do you guys think for this? Achieved or merit? Okay, so why do we think that this is an achieved? Yeah, actually, you're absolutely right, Micah. Thank you for that. I know everyone said achieved. Yeah, you guys are right. Turning points is actually wrong, because you've got that green line kind of popping up, which means you should have had, yes, it's going through. So these are the things I'd give. He's got the right shape. All right, he's got this thing correct, but the turning point should have been on the green line. As long as he's got the turning points on the green line, then this would have been a merit. Now think about this, guys. That's why I'm spending so much time on this, because this person, because of this particular mistake, they are going to get like 2 points for it. But if they got the turning points right, they're going to be getting 5 points for this. All right, that's what's at stake at the moment. You know, it's an M5 versus getting an A2. Just getting the 2 turning points right would have given this person an M5. All right, let me have a look at a few more kind of mistakes, and we can actually learn from it. What would you guys give this one? achieved a merit. Yeah, I'd be happy to give it a merit because the 2 turning points are correct, and it's going through -3, y-intercept at -3. Yeah, I'm happy to give this a merit. Oh, this is an interesting one. What about this one? Yeah, sorry, Tuan. The highest you can get is a merit. Yep, you guys are right, Unshackled Micah. Because the turning point is slightly off, particularly the left turning point, I'm looking at this one here, I would actually give this an achieved. But yeah, you're right. I mean, we could have actually said, and it's all right, you know, because I know probably people are doing this with their, I mean, this is not the best form for submitting answers, but in your exams, I'm just letting you guys know that even if it's off like that by that much, they could actually give that, they could actually count that as incorrect. So as long as you get the turning point correct, that's the most important one. And I know we're doing this on the computer and it can be a bit of a pain, but that's why I actually picked this one, because I'm assuming this person knows how to do it, but because of the computer, it actually come out like this. But yeah, Micah, don't rush through it. Yeah, just make sure you take your time. Just go through it a couple of times so it actually makes sense. I think that's basically it that I wanted to cover. What is it? I think you guys got the hang of it. I could actually give you guys one last one, but I don't even know how to give it because I've actually created all the questions in this already. So guys, in saying that, I know we kind of, for the first time, we're actually going to finish things a bit early, but that's basically all I wanted to actually work on today in this tutorial, because I wanted to show you guys the first 4 questions that we did today were achieved. Question 5, 7, and 8 were definitely merit. Unshackle, I can draw it, but the problem is I won't be able to actually give you guys feedback because I have to create a brand new code and a brand new activity for that, and that'll take me some time, and I just didn't realize that we were actually going to go through it real quickly. But you are guaranteed, I would say like 95% sure that in your calculus paper you're going to get a question like this, where it doesn't cut the x-axis doesn't matter. No, Crystalline, for the cubic it doesn't, because we don't know, we just don't have enough information. Because remember, when you integrate, you're going to get that C value. Like what I mean, let me just show you. Give me a second. Okay, so let's have a look at this, just to give you a bit of an idea behind it, all right? So say we've got a parabola that looks like this, right? So if that looks like this, then I know that this is an x squared graph. Now when I integrate it, I'm going to get x cubed over 3. But remember how you get that plus c? That plus c, basically what that plus c does is that, so I just have a look at it. Just show you guys real quickly, all right? And because we don't know what the C value is, that means you could either have the blue graph, or you could have the black graph, or you could have, so it doesn't really matter where it actually cuts the x-axis, because we don't know. And the reason we don't know is because of we don't know what the C value is. And because we don't know what the C value is, this cubic could look anywhere along that. That red one does not look right. Should have actually drawn it better. Okay. Yes, Shannon, it's coming soon, man. Just need some questions. I need to create some questions first. Just haven't had the time at the moment. So does that help, Crystalline, for your cubic question? You got it. If we knew what the C value was, what would the graph look like? Good question. If you know what the C value is, then I don't think they're because remember, if they give you the C value like the previous question we did, do you remember how we said that the y-intercept was 3? Was it 3? Is that the one we did? Yeah, like see, if they say the y-intercept is at -3, that is the C value. So the turning point any easily, hang on, let me just have a look at this. Okay, Annie easily. So this is Hugh. No, you're not, man, because your turning point is fine, but the problem is you are supposed to have a y-intercept at -3, which means your cubic needed to go through that point. So what I would have done is something like this. So go through that and then turn there. So something like that. So I would have actually given you achieved for that because you've got a cubic shape, right? But because you didn't actually make it go through -3, I would actually have given that just an achieved. But if you make it go through -3, then I would have given that yeah, that would have given you actually a merit. So who did I mess up next? So the turning point is what should be on the green line. I think you're talking about this. Yes, Crystalline, the turning point is actually on where the green line thingy is. No worries, Hugh, you're welcome. 2 equation to solve the area question on calculus level 2. Tuan, I will do that next, man, because that's actually in one of my tutorials. I'll probably spend an hour. The next tutorial, I'm probably going to be looking at kinematics. And then after kinematics, we'll do some questions on like area question using calculus. Sorry, TS. I will actually put this up on, I'll upload the video shortly. You can still do the activity, TS, and just ask me to check your work, and I'm happy to check it for you, man. Alan, I think I'm not going to do any during the holidays because I'm not actually in the city. So I'll better be, I'm going to be out for like 2 weeks, but then after that I'll be back in full swing for the final stretch. But yeah, guys, that's it for the tutorial this session. I will hang around for a few minutes if you have any questions. And this video will get uploaded to YouTube in about 15-20 minutes once I stop the stream, so you guys can catch up on the tutorial later on. No worries, you're welcome, guys. No, Micah, we all get paid the same. All teachers get paid the same. Do you have set calculus tutorial time, level 2 maths time? Maya, at the moment, the level 1, I've finished the MCAT ones, so I'm going to be spending my next few kind of weeks working with level 2 guys and level 3 guys. Just keep, I think I usually put up a community post, but just keep put your notifications on, I guess, or just keep checking the community page just to find out where it is. I just haven't figured out how I can communicate with you guys in terms of what's the best form of communication for tutorials. You're welcome, Krista. No worries, Zach. Quadratic formula with a tangent equation. TS, I did a tutorial, I think not the last calculus tutorial that I did on the 9th. You're talking about these types of questions? Yeah, so I did this on 9th of September. I just spent a whole session on tangent stuff. So you can actually find that tutorial. It's uploaded. No worries, Alan. Night Shadow. No, I don't do physics, man, unfortunately. No worries, Khadija. Welcome, Angie. Yeah, Unshackle, this was something that I've done for the first time, man, because I was very nervous thinking about putting it like this, because I mean, there's always people that are going to kind of do silly things, but I think hopefully majority of you got something valuable out of a session like this, because yeah, like it was just a pure idea that just came up. No worries, you're welcome, Maya. Crystalline, do these questions go only till merit? Yes, Crystalline. I think someone asked me earlier, do these questions ever come as excellence when you have to do a double diagram? But I have not seen a double integration in a long time. You could get a double differentiation, but I doubt it, because the way the paper is structured is that I don't think they have space for like 3 grids. Like if you look at an exam paper, they've only got like that A4 paper, so they don't want to. They usually put the 2 grids back to back, so it's easy for you to draw. So they wouldn't have it like another different one. Night Shadow, yes, there's heaps of kinematics and calculus stuff. So we do it in level 3 as well. Level 3 integration, we do quite a bit of kinematics. Yeah, Micah, it's kind of stink in a way that they've done that, because like if you understand integration, you can actually use the maths formulas in physics, but then they don't accept it, and if you use physics formulas in maths, they don't accept it. Night Shadow, no, that would not be. I mean, we just drew a cubic, that's a merit. So this particular graph here that you're looking at on screen right now, we've gone from a parabola to a cubic, so it will definitely be a merit. No probs, guys. It's just trying to help out people, so it's all good. All right, if there's no more questions, oh no, wait, we've got one more. Oh, tell me about it, Micah. Jeez. I think that's why I Sweet. Thanks for the feedback, Crystalline, because yeah, I was nervous trying to do it, but I think it actually worked really well with you guys, so that was really good seeing that work. No worries. See you guys. Get some rest. Alright guys, if there's nothing else, oh wait, what's that? I have a question. Do you do cubic tangent question, because that's e-parts? Yes, TS, we did do cubics. What do we do? We got a quadratic there, we got a quadratic there. Oh, you're right, we haven't actually done cubics yet. Okay, TS, something for you next time. We'll actually keep that in mind. Yes, Zach, they get saved, so you can watch them later. It's actually on my main homepage. You'll find it under tutorials. So what I might do is I might just put a new page so that all the tutorials are right at the top, so you guys can just catch up with the live streams. Rate of change, I probably would be doing that with during, not kinematics, but I'll probably do it with some area questions. TS, just send me a screenshot of that question, because I know you sent me a couple of questions. It's on my list to do, but yeah, just send me a screenshot of the question. I'll have a look at it and do it for you, man. Next stream, Night's Shadow. I'm not sure because this next week is a bit messy for me because I have to give a. I've got a couple of events happening on Tuesday and Thursday, so it's a bit tricky for me. But I want to do. I'll have to check in with management at home, and then depending on if I need to, if I get some time off, then yeah, I'll probably just give you guys like about 15 hours notice. But I've got something happening on Tuesday night and Thursday night as well, so that's when I usually do the streams. But those 2 nights are a bit tricky at the moment because I've got events happening outside. So, but if something happens, I'll just post it up, guys, and I'll put a community notice up there. So sorry, man. Like, yeah, this next 3 weeks is a bit messy because I'm not in town as well. TS, what I also do is usually TS, what I do is I also put community notifications. I don't know if you get that. So yeah, like in this part, I kind of just like I just put a little message there. So in the community section, so that's just another place to look at. Okay, since you guys, I know there's only 13 of you guys are here, but like, what's another way that I can actually give you guys a notification that I'm having a tutorial on? Oh yeah, try. TS, try Night Shadow's idea. Have you hit that second bell? Because there's like, you have to subscribe and then hit the bell. I don't think okay, Insta's an ID. Instagram. Okay. I could do an Instagram post, like a story on Instagram. Would that help? Yeah, some ideas to think about. Okay, well, we'll have a chat again next time, guys. But that's basically it. Go get some sleep. And TS, make sure you send that question. Yeah, they don't give notifications. You're right. Yep, sweet. Thanks, TS. And I'll catch you guys next time. All right. No worries. Who was the last person? Khadija. Catch you.